Hello and welcome to this podcast for Electropages. I'm your host, Robin Mitchell. Today we're joined by TeleCANesis, a company with a rather unusual name that you can't find on Google, and we'll get into a bit more as to how that name came up. But just before we dive into all of that conversation, please tell the audience who you are, what you do, and what you like to do in your free time.
Hi, I'm Rodney Dowdall. I'm the VP of R&D here at TeleCANesis, the site you can't Google. I like to write code. Code is a fun thing to do. In my free time, I'm Canadian, so I play hockey and soccer.
Fantastic. So coding, hockey, and soccer. Oh, whoa. Soccer. No. Hockey. Coding, hockey, and not soccer. Football.
Football.
This is a British podcast. Yep. We shall give it the proper name it deserves. Football. The Americans called it soccer.
Yes.
Regardless.
We are having the Football World Cup in Canada this year.
So you absolutely are. So it's all going to be all very exciting. Hopefully England can bring the game home, which they absolutely won't, and they never do. So,
hey, I'm Canadian. I'll admit I cheer for the Toronto Maple Leafs. That franchise might be the most poorly run franchise in the last 60 years of any franchise. So I feel for English fans, and if Canada doesn't go far, I'll be rooting for England.
But you know what? At least they gave it a shot.
They showed up. I do think that English football fans have one of the greatest World Cup chants out there. I think.
Hands down, our chants are absolutely diabolical and brutal.
You guys know how to cheer on your team. Especially when you're playing Germany. I love watching those.
I think it's less about cheering on our team and more about insulting the other side with every possible insult 100%. We can possibly find. Yeah. But I take that with a bit of pride myself.
Yeah. Are you an English Premier Football League fan?
Honestly, no.
No?
Okay, I just have to like it, as a cultural thing. Like my dad, my parents, my whole family are from Leeds and Liverpool, that area, so they're all very into their football. But honestly, I never really quite got into it. But hey, that's just me. I'm an engineer. I like to code. I like to do PCBs and stuff like that. So that's the kind of, if there was competitive PCB designing, I'd watch that.
I've often said, I've worked in a lot of very interesting workplaces over my career, and I've often said, sometimes there should be a video camera rolling, and we should actually roll that out as a regular thing. I worked in tech support for probably the first 5 years of the start of my career, and there were some really good, I want to say months, where you could get a lot of good stuff after, out of that group for the first couple of months. Yeah, it was good.
One thing I will quickly say, there is such thing as competitive Excel spreadsheets.
No,
it's a genuine sport. I'm not quite sure what they do, but they get a challenge and they have to do it as quick as they can. And these people are going mental on these spreadsheets, and it's absolutely amazing to watch. It is a genuine sport.
Crazy.
Imagine that. Next World Cup Olympics is going to be, and the gold for Microsoft Excel, and it's just going to be absolutely crazy. Right. Sorry, Karen.
Wild. I don't think I'd do good in it, but I'd watch it, I think. No.
Not for me, no. Python, yes, but not spreadsheets. Anyway, right, let's get on to the point of this podcast. Tell us a bit about why you're here today and what you want to share, because this is a very interesting company and the things that you develop. So just tell the audience what it is that you guys actually do.
So we're making a product. It's called TeleCANesis. It's spelled wrong on purpose. So the CAN part of it comes from the CAN protocol, which is used in a lot of automotive applications. And then the second part is we're Canadian, so it kind of fit. So TeleCANesis. That's the big reason why it's there. It's a product that comes from solving a real world problem, which I love products that solve real world problems. I've now worked for 2 companies where they were born out of this repetitive workflow that was happening in a lot of companies that was taking a lot of time, and it was onerous, and people didn't want to do this. So in TeleCANesis' case, it comes out of the fact that when you're working with the CAN bus, those messages have to be described by a particular data file. And hardware manufacturers seem to really like to change those messages a lot. And so you get these updates to this file over and over and over again. Well, when you're writing code, as you know, that means that you have to go back in and rewrite your code over and over and over again to make sure that those messages line up, right? Because when you're reading data off of the CAN bus, it has to know, what the data means, right? You have to describe what the data means. So we were spun out from another company called Arcane4, and Arcane4 was doing a lot of this work, and they said, if we just had tooling around doing this setup and this connection, we could save a lot of time. So they built that tooling. Then we started to realize, well, there's other protocols out there, ISOBUS, Modbus, EtherCAT. Like there's a lot of things out there that kind of require the same sort of tooling. We should just roll that in. And so this is where TeleCANesis really started to roll. And then what we started to realize is there's a lot of protocols now out there to sort of connect other machines up, like the cloud and web pages and your phone. And they use a different protocol. They use, typically they use something like JSON as the binary encoding, or not binary encoding, but the encoding for the data as it's coming through. And so we thought, well, it'd be really cool if our tooling could take something from the CAN bus, understand it, decompose it, recompose it into something that a web page will understand. So we can just push it through. And we'll handle all that decomposing, recomposing on our side. And we wrote tooling around it so that you can configure that decomposing and recomposing however you need to do that. And what that does is it saves you a lot of time in having to write that code that is necessary for your product to work, but isn't really all that interesting for your product to work, right? Developers, I think, really like going after the challenging problems, and how to take this bit and stick it in this bit sometimes isn't the most challenging problem that you can solve. So we're trying to solve that problem for you, so that you don't have to worry about it, and then make it easy for you. Inevitably, when those messages change, somebody comes in and says, "Oh, actually now we're changing the battery message to have 2 UINT16s instead of 1," and you have to handle that flow all the way through. We're hoping that with our tooling, you don't have to spend hours and hours and weeks rewriting the code that deals with that message.
So I'm just sort of hearing everything you're saying, and I've got a weird feeling I've actually seen your solutions before. And you're telling me we haven't actually had a conversation before, because I feel like I know about this. I think I know about this. Maybe I saw it in Embedded World or something, because
we were at Embedded World, so you may have stopped by and I may have given you a demo.
Because I remember someone talking about a solution that basically sat in the middle of all these different buses and turned it into essentially what was a single unified type of file. And then from there you could see all the data, and then it became more of a software problem as opposed to a hardware problem. Yep. I'm sure I remember this. But it's funny you mentioned about JSON, because in my opinion, JSON is like the superior data format in my opinion, because I appreciate it's ASCII text, so it's obviously expanded a little bit, but honestly, in my opinion, it just wins hands down over every other message format I've ever seen.
Yeah, I agree. I think using JSON over and over, it definitely has its perks. It's funny. I find a lot of engineers shy away from human readable configuration. Like a lot of people seem to think, like I've dealt with a lot of engineers over my career that seem to think that strings are somehow inefficient, and they can be. I mean, if you're creating like these super long strings that have to be memory compared all the time, then yeah, it could get inefficient. But at the end of the day, I think most processors now can handle a memory compare pretty optimized. So strings aren't as onerous as they used to be, and also we've got tons of memory now, so I don't think we need to be afraid of them.
Well, for me, the way I see it, like you say, is that modern microcontrollers are good enough now that they can handle that kind of data. If you're worrying about the extra few bytes that you've got because you're dealing with JSON, then you've probably got bigger problems to worry about. Because you must be like so memory constrained. But when it comes to sort of like, it's not just about the fact that it might be It may be less efficient, but it's the fact that it's the time and the effort that it saves, and the fact that it makes things a hell of a lot more bug-free. Because, in my opinion, well, actually, a great example would be something like the REST HTTP protocol. You can't really send raw bytes across the internet without having checksums, because if any of those bytes go wrong or anything, you have to try and figure out what it's supposed to interpret. So when you expand it into strings, it becomes a lot more robust anyway. So it's harder to make the data sort of corrupt, because you've got more bits to represent it. So that's why I think JSON is just an absolutely beautiful data format, and like you say, engineers who shy away from it are probably shying away from it for the wrong reasons, and they're still stuck maybe 10 years ago when microcontrollers only had 16 megahertz, 2 kilobytes of static RAM, 2 kilobytes of ROM, and you're kind of like, okay, yeah, I can't really deal with JSON, but these days we've got like 100 megahertz CPUs. They cost $1, and you get like a megabyte of static RAM anyway. So like you say, JSON just makes a lot of sense. And as you move to these more powerful platforms, the resources it takes is barely noticeable. But the benefits that you get is that you get this kind of like almost reusable template that's not hard coded, and it kind of lives in a more virtual space. And so it becomes a hell of a lot easier to split that data up. But my quick question about how your solution works. So I'm a hardware guy, and the way I would understand something like this is that you've got a PCB with all your different sensors and all your different parts. and then you'd have some kind of central controller. Are you saying that your solution fits on a central controller that sits on the bus, or is it something more abstract?
It's software. So ours is a software middleware stack that basically the runtime component of it is a software that runs on the chip that understands how to read off these buses and then convert the data and then send it back out over some other protocol, right? So you can hook all these different things up. I use this the example of thermostats. So for example, if you think back in the day, your thermostat just had to control heat and cooling. That's it. You slid a little dial, and it got hotter or it got colder, and it only had to talk to your furnace or your air conditioner. That's all it had to talk to. And now, if you've got a Google Nest, well, it's still got to talk to your furnace and your air conditioner, but on top of that, it's got to talk to your calendar. It's got to talk to your phone. It's got to talk to who knows what else, right? Some database somewhere in the cloud. So now, the data that is coming off the furnace and the air conditioner, well, they're not cloud. It's not cloud friendly data. It's raw bytes off of an actual sensor somewhere that you're pulling in, right? That has to be converted into something that the database will understand, or into human readable, so that somebody can look at it and say, oh, look, there's this fault occurring there, so that you don't have to have somebody show up at your house and watch the blinky light and count it and say, okay, it's three bleeps, so that means that it's that sensor, right? Now we can actually read the data and say, yeah, it's your air sensor. So that TeleCANesis, what it's solving that problem is it's making it very simple to pull that data off, convert it into something that something else is going to understand, and then also conversely send from that database or that web page back to the device, and in something that the device understands. So that's the goal of it. The runtime component, the middleware part, is basically just it's a way to facilitate really what the power is of TeleCANesis, is the tooling and setting all these things up.
And so as a sort of like a basic example, let's say I've got a microcontroller board, I've got a bunch of sensors on there. Let's say an I2C temperature sensor and a humidity sensor. In this aspect, what would happen is that I would have some kind of I2C driver or some kind of interface, and that would be patched into the TeleCANesis.
Yep.
And then you would tell it what the different registers were and what they were sort of meaning, and then it would effectively build up that singular JSON file that would then go to wherever you need it to go effectively.
Yes. So well, actually, think of it this way. You can configure it however you want. It could be a single data file. It could be like multiple messages. It really doesn't matter. You can configure it however you want. So what you would do is you would use our tooling. You would say, I've got this at this address, and I want to read this number of bytes. However, the middleware stack is completely plugin based. So there would be a plugin that understood how to talk to your I2C devices. Whether we wrote it or whether you wrote it, it would be up to you, but you would plug that in, and then you would get all the functionality that TeleCANesis provides, which is, the ability to route messages, the ability to translate messages and reroute messages, the ability to ignore messages that you don't want to really send out. So yes, exactly what you were saying. The only difference is that when the middleware gets the data from that I2C device, it will then figure out, okay, I know that I need to send this messages through MQTT to this server over there and use this message address or this message name, and I want to convert it into binary JSON, or I want to convert it into JSON, or I want to convert it into just raw packets or whatever. You will configure it however you want, but you control how the data is coming off you don't control how the data is coming off the device. You control how it gets repackaged and sent out, that sort of thing. And then you can also control how the message is going to come into TeleCANesis and how it's going to interpret it and then send it back out onto this data or onto this device so that it can react to some other message.
Now, this is going to be a bit of probably a naive question, but in terms, because what I'm trying to figure out is kind of like what it is that makes it truly powerful, what makes it really, really important for an engineer. And so what I'm thinking in my head right now is that why would I not just sort of in this scenario, why would I not just instead create a simple function that just takes that data and puts it in a certain, JSON appearance and it just sends it out? Like what is it extra that's going on under the hood?
So the challenge there is that when the data changes, so now you have to go and refactor that code, right? So the thing is that if something comes along and they say, okay, well, now we're going to switch out this sensor and we're going to put in this sensor, or in the case of the CAN bus, right? For example, they give you a whole new DVC file. Now all the messages are like this. You have to rewrite that function. So in our case, all you have to do is drop in a new configuration file and you're good to go. No code changes. So because the code doesn't change, that means you don't have to recertify anything. You don't necessarily have to retest. I mean, you should probably test to make sure the messages are still going through. But code changes are what causes a lot of problems when it comes to software engineering, right? When we change the code, we're now not sure what's going to happen after we start to run it, right? Like we have a good idea, but we're not 100% sure until we test it, right? And then sometimes people don't test, right? I mean, it happens where engineers get flustered and they're pretty sure that what they're doing is safe, so they put it in and then they run it, and then inevitably bad things happen, right? So what we're trying to reduce in that time frame is the fact that you don't have to rewrite that function, so you don't have to worry about it. You just have to drop in this new configuration. So it's quick to change things. The other side of it is if we've already written that function for you, now you don't have to, right? So now you can just drop it in and it works. One of the challenges that we have also noticed on the Arcane 4 side is, people sometimes get overwhelmed by what you have to do with things like CAN and Modbus. They're a little obtuse. Yeah. They're a little obtuse when it comes to using them. And so, if we can provide a ready off-the-shelf, this thing will talk to your CAN and it will understand all the messages on your CAN bus, then, we've saved you time and effort on that side. And then you basically can now focus on your back-end business logic, the thing that's actually going to make you money, and make sure that that's rock solid, right? And so, what are you doing with the data?
And so to me, as an analogy, it kind of feels a bit like, it's a little bit like drivers and something like Windows or whatever, right? Like an operating system whereby, if let's say NVIDIA take a graphics card, for example, they change the graphics card, they change some kind of feature, so when you install a new one, suddenly it completely stops working. The choice is either you rewrite the drivers from scratch and rewrite all the functions and try and edit all the register variables and how it all interacts, or straight into as a configuration file and it's done. And because you haven't messed around with because the fundamental code hasn't changed, your pathways in the code haven't changed. The ways in which the code flows hasn't changed, and that, like you say, it's essentially protecting your future code from idiots who might put weird things in when they shouldn't be doing and trying to refactor your code 5 years when someone's already retired.
Well, and that's the thing, sometimes these things happen, or 5 years down the road you have to change because that part's not available anymore. That's another thing that the advantage of going this route. The way I sort of explain this to people, if you have any experience with GStreamer and how GStreamer works on Linux, where it basically is able to take different video and audio streams, different media playbacks, and then kind of push them to different areas like RTSP or to your screen, and it does this whole pipeline configuration thing that it sort of auto negotiates and figures all that stuff out for you. It's similar in that respect. It's but instead of working with media, we're working with raw data. So that's kind of how I like to explain it to people sometimes.
And you mentioned about CAN bus in particular, because I personally think CAN bus is an incredible concept. In fact, when I actually discovered, when I first learned about specifically how the addressing works in CAN bus, I was quite impressed by the fact that the devices know that they've lost priority because something else is pulling the line down during the address part. So then it knows, like, it can't be me then. And it does in the way that the binary bits work means that the highest order always goes first, sort of thing. So I was honestly absolutely blown away when I discovered all that. But I didn't realize that, like you say, developers and designers will change things quite frequently. Now, when you say that they're changing things frequently, do you mean in terms of a system as a whole? So let's say you've got a vehicle and you put a new sensor in, or do you mean like even the actual silicon itself suddenly decides to change?
Well, the firmware that runs on the silicon can change. So basically what will happen is that, so for example, a battery manufacturer might want to expose more data or restrict data that the battery will produce, right? And so they'll update the firmware, which means that the messages that the battery is now sending out over the bus could change. And then that means that your code now has to change because what they're producing on the bus isn't what they used to be producing on the bus. So now when you're reading off the bus... Just
to interrupt you very quickly, this is really funny because this comes back to the concept of JSON. See, if those buses produced JSON, you wouldn't have this problem because the data variables wouldn't change. It would just have extra stuff that you could ignore.
Yeah, exactly. So, and this is the thing, right? So, unfortunately, those buses are very binary centric. So,
yes, they are very binary centric.
You've got this uint64 that you can dump some stuff into, and then the data file really describes what you're supposed to do with that when you pull it off. And then on top of CAN, like just raw CAN, like that's raw CAN. You've got other protocols that sit on top of that, like CAN Open, J1939. Those protocols offer even offer more functionality and features for the CAN bus itself, and that adds another layer of complexity to what you're trying to do. So we support those protocols on top of CAN bus as well. So again, you don't have to worry about setting things up. You can use our tooling, which is hopefully intuitive, that says, okay, I want this message every 250 milliseconds. I want to send this message every 10 milliseconds. And then the middleware will take care of all of that for you. You don't have to write the code that does that. And quite honestly, you know, like that type of code can get very monotonous, right? And then further to your point about JSON, so now you've got these CAN bus messages that changed, and so they're sending different pieces of data, or their names have changed entirely. Well, now you've got to line those up to your MQTT messages that are going to be sent out to your web server, or, you know, your phone or wherever. So you don't have to worry about changing that either. Change the configuration file, the new message is sent, and then on the other side, you can have a TeleCANesis running that will then interpret the new message, push it where it needs to be. Or part of our tooling is to generate hooks for those messages into your code. So we'll generate Python hooks, C hooks, you know, Kotlin code hooks, so that you can then import those messages right into your code, compile it as part of your code with the stubs that actually do the receiving. And now you've got these cases already built in for you, so that you know the messages that are coming in. And again, that is actually one of the failure points that happens a lot in this sort of software paradigm when you're dealing with messages, is somebody changes a message name, and then all of a sudden the other side doesn't see the message again. And it can take a while before people realize that, because in today's world of how we're doing development, you've got remote teams. You know, I'm responsible for the web server, so they know about the web server, and the feature documentation, or the requirements documentation said these are the messages I need to worry about. So they code them up, and it has this data. And then the team over here has decided to change everything and forgotten to update the requirements docs, or, you know, forgotten to kind of go through. And we put processes in place to kind of catch these, but things still slip through the cracks, right? And so what happens is now that server is not responding to those messages. With our setup, it sort of puts all the messaging and what the data structures are in one single place as well. So with our tooling, you can kind of see it all laid out, and it's like, okay, these are the messages and here's where they're going. And then so you can share that with people and say, okay, well, and then when you have to update it, because you have to update it for this thing over here, the flow through just happens. So now it's automatically been updated. So now you can now reshare that with people and say, okay, well, these are your new messages. And so the goal is to reduce sort of those gotchas where it's like, oh, the message name changed, or, you know, in the case of JSON, spelling mistakes happen. You know, like we're trying to you know, simplify that process a little bit.
Making that configuration file a single source of truth.
Yes,
exactly. And so, like you say, you can share that on a network drive. If I decide to just change all the message names, it doesn't matter, because there's some other guy's software is going to pick that up and just go, well, I've already loaded it all up anyway, so it doesn't matter.
Yeah, exactly.
Which sounds like to me, it's kind of shifting like the nature of programming itself into more of a more abstract kind of, like, I don't know how to describe it, but it kind of feels like it's making code more fluid effectively.
Yeah, well, I think what code is trying to do overall, I think you know, software engineering and even hardware engineering, it's an organic process, right? Yeah. We build and we move forward, and we try and do, and we've seen this over time. Like, you know, I won't say my age, because of, you know, we kind of got into a whole conversation there earlier, but you know, I've been doing this for a long time, and what I liken it to, what I've noticed over my time in the software engineering world, is that, you know, back in the day, when I was going through school, I was really concerned about Visual Basic. Like, honestly, I was very, very concerned about Visual Basic, because I was like, I was a C programmer. I was going to school to be a C programmer. I took a little bit of COBOL just because, you know, it was around the 2000s when I was doing this.
Just going to warn you very, very quickly, do not insult Visual Basic Studio or
VB.NET.
Don't do it in front of me, because I think that is one of the best things for making GUIs, because I do think it's. I may not like Microsoft's environment. I may not like I may not like VB as a language. But in terms of the GUI editor and then the coding and the events, I do think they've got that spot on.
So I'm not going to insult it. I'm actually going to give it props. I looked at that and I said, I don't know if I'm going to have a job. And because I looked at that and I said, this thing is going to make it very, very easy for people to come in and just write code and do things and program. And I had a friend that I was sharing this concern with, and I was like, I don't know what programming is going to look like in 5 to 10 years, right? And then this was the existential crisis I was going through when I was in school. And my friend looked at me and goes, you will be able to do more. You'll be able to do more with the tools because you will have a better understanding of what the tool is doing underneath the covers. So don't be afraid of tools. I have the same feeling. I hate to take this down this road, but I have the same feeling kind of like AI. People are afraid of it. Like, yes, it there's the whole replacement storyline that's going on. I'm not sure I really follow that storyline. I use AI on a daily basis. I'm not afraid of it. I can do a lot with that tool.
I will attest to AI in a few ways. So obviously, I don't like the concept of people losing their jobs as a result of AI, and I'm sure most people hate that. And I always have this argument with a lot of people because people say like, oh, every time there's been an industrial revolution, people find new jobs. They go, but in this case, it's not the same because there are no new jobs. That's the problem. It's just closing the ones down. But what I will say is that since I've been using AI with my coding, I don't let it write my code for me per se. I determine the system architecture. I determine what the functions are going to do. But what it does for me is it gets rid of all the boilerplate code that I don't need to worry about. Because take, for example, I recently built an entire web framework from scratch, using PHP backend, all that kind of stuff. And the reason why I did it was because WordPress is too slow, too sluggish, and rubbish, right? It's full of security holes. So I built a whole system from scratch, defined everything I was doing. I manually made parts of the code. Then I'd say to the AI, look, I haven't got time. Write this class function for me that goes into my database and pulls a variable and make a nice helper library. And it would do that. And what it meant was that instead of spending all my time doing code which I already know how to write, it just did that bit for me, so I could focus on the bits that were actually important, like the security features or the user login system. That was what I had to focus on.
Or just the basic functionality of what you would design from an architecture level, right? Like whether or not that architecture actually made sense. And these are the things that I think get lost. Those are the parts that, I find AI is great for those things. I think AI is great for repetitive tasks. Computers have always been great for repetitive tasks. Like I think now we're just leveraging them a little bit more. But you still have to kind of come back and reason at some point and say, like, is there a better way to do this? You have to ask certain questions as you're going through and doing things.
Absolutely.
And today, AI is not there. Now, could it be there in 15 years? I don't know. I can't predict the future. We'll see what happens. I'm not going to worry about a future that could be. I'm going to worry more about what's going on right now and how I can leverage what's currently happening to the best of my abilities, using as a tool. I agree with you. I don't think people should lose jobs. I think that's, I think some of that is just, to a certain degree, trying to soften the message. Maybe not soften the message is the right term, but you know what I mean? Where it's like, oh yeah, we're laying people off because of AI. It's like the cliche thing to say now at this point, or the accepted thing to say at this point. Whereas saying I'm laying people off because our stock's in the tank, people would be upset about that, right? So if you say I'm laying people off because
we're making the company more efficient, more streamlined.
Exactly. You should invest in my company because now we're more efficient. But if you take a look at their stock prices, these layoffs are all happening when their stock prices are in the tank, right? And so
one famous Oracle, we're getting rid of people for AI. Go right.
Yeah, exactly. And so these are things that I think sometimes the messaging doesn't quite line up, and you're even seeing some of that messaging come out now where you're seeing people say like things like a lot of economists have started to look at the cost of using AI versus the cost of using a human, and in certain cases the cost of using AI is actually more expensive than using the human.
It absolutely is.
The numbers aren't quite jiving in some of these cases, so I think there's a push there to kind of push the technology forward, which we will always do as a human race. We will always push things forward.
And I'd add to that I reckon the next 5 years. In fact, we've already actually seen this happen about a year ago. I suspect that when people try and use AI entirely for a software solution, because what you must never do is say, write me a program to do this, done, and then you expect it to just produce the whole thing. Like for example, researchers recently used AI to design a RISC-V chip. They actually got it to verify but the thing is, though, in reality, you wouldn't want to use it because it had so many flaws and issues. And what I think will happen in the next few years is there's going to be a lot of cases of big companies using a lot of AI software, which I think Microsoft did actually, and then they find out that it's got glaring flaws, which end up in massive security issues. And then they have to pull it all back and go, well, actually, we need a human in the loop. In fact, I'm sure you know this one, but did you see when they decided to add a Markdown and AI into Notepad, and what it ended up doing was giving it a literal root access attack, because all you had to do was paste something. What was it? All you had to do was paste something in, and the AI would outright execute it as an actual privileged instruction on the terminal. It would open up a terminal and do it. So if you just put in whatever you wanted, someone could literally just go, right, use Notepad to launch anything I need. And they had to pull it immediately. But this is the point, isn't it? Because, if you take humans out of the loop for a lot of these things, things do fall apart. So it's just interesting to hear that to also hear that side from another engineer, because, like I say, AI, it's scary. Yes, at the same time, I'm using it all the time because it speeds up my job, and I spend more time doing the interesting stuff.
100%. I think that's the thing. Like, I've read a lot of stories about AI burnout and things like that. Luckily, I haven't experienced that. I think it does. It does allow me to do things, like you say, it allows me to focus on the interesting things a little bit more. It allows me to, what I find it really useful for is writing test cases and automating those test cases. So I get a lot of the testing out. So, do that. But I still want to hire a QA person to come in and do that part. I don't want to even have to do that part, right? I want somebody to leverage the AI to do that. And then I know that QA person, when I talk to them, they'll be able to explain to me what it is that they're trying to do, right? We seem to get really worked up when we invent new tools. I think that's what it boils down to, right?
That's humanity, though.
Yeah, I wonder if, like, when the tractor was invented, I wonder what people were thinking. Like when somebody came up with a new type of shovel, like was people were
we don't need no iron shovel, we need a bronze shovel.
My wood shovel works just fine. It's like, but your iron shovel will last 50 years. You only have to buy one of them.
Absolutely.
Well, what are the wood shovel people going to do?
Exactly. But it's interesting to take it back to your solution, TeleCANesis solution. What you're offering essentially is kind of like that. It offers that kind of environment in terms of the fact that you don't have to worry about trying to do the little things all the time, recertify your code. It's a drop and forget effectively solution.
Yes, and so people have brought that up. Like, why wouldn't I just use AI to do what you're doing? And I suppose you could. But at the end of the day...
Would you really want to, though?
So one of the things that we're going to do, what we're working through right now, because you have to have, in order to get certain safety certifications, you have to go through a certain time period, right? So we're working towards getting our safety certification. And our code will be safety certified. And the code that our tool generates will be safety certified. So if you need certified code, we will have already gone through that process of making sure that what we're producing and giving you is safety certified. So in highly critical projects, you're still, like, if you get AI to produce it, I've Googled it. I don't know if I've missed it, but I don't know of a safety certified AI yet.
Well. The difference is that your system produces code using deterministic principles. So it will always produce the exact same code every single time. Whereas AI, because it's got that randomness, it can throw things differently, and then you can't predict.
Yeah, and then that's what screws up your safety certification, right? Because safety certification is all about predictability, right? And so this is the thing that I think companies are going to run into. So I was thinking about this morning because I knew I was coming on this podcast. So this morning I was thinking about how AI and stuff sort of fits into different things. And the thing that I realized is that I find that a lot of the AI stories, at least where people are talking about vibe coding and those types of stories, I find a lot of them tie back to general purpose applications that run on the web or your phone, or more consumer level applications, right? There isn't a lot of talk about vibe coding an embedded product, like something that has to go in a pacemaker, so there's a lot of things like that where I think if we start to peel back the onion a little bit, it's like, AI is great for putting up an enterprise grade web page that can handle, click and collect and all that stuff. But, like, do you really want are you okay with like a completely generated pacemaker that had no human intervention whatsoever?
In that case, this is the big thing, right, for me. The engineer who designs it or vibe codes it is not the one who's getting it put into them. And it does kind of remind me a little bit of that joke. What is it? The professor sits on a plane and someone tells him it was made by his students, and everyone gets off, but he doesn't care because he knows it's not going to take off anyway. So you know that joke, So it kind of reminds me of that. But it's a bit like that. It's like, I'm not going to be the one who's using the pacemaker, so I don't mind putting some vibe code in there. But it's like, maybe you should, because it's like, exactly. it's like nuclear submarines. I'm pretty sure, if I remember correctly, that in submarines, every single part that goes into it has to be verified by someone on the crew or something like that, because they're the ones whose lives will be dependent on it. So they have to make sure that everything gets through someone who's going to be on it effectively.
Yeah, there's something like that standard. I don't know the exact standard, but there are a lot of standards that are in place where it's like, look, like this has to go through multiple hoops before we actually allow it to be utilized. And I think I think that's where a lot of the applications for, software, hardware are going to go. Like when we look at where we sort of want to expand our technology, we've done a lot of consumer expansion over the last 20 years, right? There's been a lot of consumer expansion. I think we're going to pull back on that a little bit. Like if I had to predict, I think we're going to pull back on that, and I think we're going to start diving a little bit more into medical expansion of things. Where we can use AI to leverage how we're going to do things differently. For example, with prosthetics, things like that.
Well, the thing about the consumer side is that and this is an argument I always have with ChatGPT. Yes, I argue with ChatGPT about things.
Hey, I do too. I know exactly where you come from. I actually have a text document somewhere about me talking to ChatGPT or Claude. I can't remember which one I was using at the time, about how AI is going to eventually replace humans. So, and it was what I loved about it was complimenting me while also telling me that I was.
I know. No, well, I had real heated discussions, and one thing I kind of believe is, because you're talking about consumer applications, I do feel like that I think most problems in that field are solved now. So take, for example, I remember the conversation. So I said, like, what do you think computing is going to be like in the next 40 years, right? And then everyone goes, quantum mechanics this, and it's going to be flying cars that, and devices will be blah, 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 blah. And I've got a theory, which is that I reckon the desktop PC will not change much in 40 years. And the reason why I say that, because not only in the past 40 years has the x86 architecture, for example, stuck around, but more importantly, I think what people use machines for currently over the past 20 years hasn't actually changed. We still have websites, we still have browsers, we still have operating systems, we still have windows and folders and files and whatever. So I kind of get the feeling that in the next 20 years, I do think that, HTTP will still be a thing, IPv4 will still be a thing. As a result of that, HTML will still be a thing, and JavaScript will still be a thing, and CSS will still be a thing, because they work, and you can't really get more efficient than what's already working. So going to the future, like you mentioned, I do think that I think the only thing that can change now is that you can make them more efficient, make them more memory conservative, make them better performance. But I don't think in terms of like, there's not going to be like, suddenly you stick a chip in your brain and you can suddenly use it. I just don't see that happening in the near future.
I think the challenge there is, and I was actually having this conversation with somebody about AI too, and I think, we look at self-driving cars, for example. And
not going to happen.
There was promises that we'd all be doing self-driving cars by now, right?
Yeah.
And we're not. And I think the issue there is like the human race kind of has this reluctance to sort of move towards some of these things, to give up some of these things. And I think that actually pushes us to kind of fall into this pattern and say, this is the pattern for it. And it only changes when something really changes the game, when something comes out. Like the PC was a game changer, right? It came out, and so what's the game changer after that? And like you say, chip in the head, I don't know if people have the appetite for that, right? Like, because then it's like, where's the line starting to get drawn? Some people sure would have the appetite for that, but a majority of the 8 billion people on the planet, I'm not so sure. I don't know if they would, And so, that's going to hold back a little bit of what we can do, but that doesn't mean that we're not going to be efficient or making progress in other areas, right? Like, just because we can doesn't mean we have to. Like, even with the AI stuff, this was the other thing I was thinking about with AI this morning, because I knew it was coming on your podcast, was that, AI speeds a whole bunch of things up, but I don't hear a whole lot of people asking the question, like, do we really need that fast? And I take this back. I used to work for a UI runtime company. We made an embedded UI runtime and tooling around that. And I used to get this question all the time where somebody was like, okay, like I'm updating this data every 1 millisecond. Can your UI keep up with that? And I'm like, you want to update something on the screen every millisecond? Yeah, I have to update this value on the screen every millisecond.
Can you?
And I would go back and I'm like, you don't have to. And they're like, no, like I'm getting it every millisecond. I got to put it to the screen. I'm like, no, you don't. And they couldn't understand where I was coming from sometimes, and I'd have to really explain to them, the human eye can only read at 24 frames per second. Like, if you're updating it, they're not going to see it. The human brain cannot pick that up. Like, you're going too fast. Like, there is a human limit to where we can go, right? And so with AI, yes, it can do everything faster. It's way faster. But do we have to? Do we have to go? Like, does the human being? Do I have to produce a new web page every 20 milliseconds?
And
no.
I'm so happy you said that, because I get to bring up something very, very quickly, slightly off topic, right? So
Sure,
I do a lot of work with AI. I train my own models and stuff, and I like to deploy models and play around with them. Yeah. And one thing which I've done, which I'm actually planning to make a video on this because I think it's quite cool. So when you see people talk about AI and deploying local models, Llama, whatever it is, they go, oh, I've got an RTX, whatever, and it does like 20 million tokens a second, right? And everyone on Reddit, and Stephanie, everyone knows there's definitely a Reddit problem, but everyone online seems to have this obsession that like your GPU has to be so powerful, it has to be able to do, if it's not doing 20 million tokens a second, it's a rubbish platform. You can't do anything with it, right? I have a bunch of servers there. I don't know if you can see them. This is a real background, right? I've got a bunch of servers, and one of them is an AI server, and in there are two NVIDIA K80 graphics cards. These things came out in 2011, right? They are, wait for it, they are, you can pick them up for about $60 each, right? But wait for it, each one of those has 24 gigabytes of VRAM. You can put them together in parallel, and as a result, I can run massive models at maybe 5 tokens to 3 tokens a second. Now, someone goes, that's rubbish, right? Here's the thing though, I can't read faster than 5 tokens per second. So while it's coming out, I'm just reading it like this. So, and this is, I think like you mentioned, yes, it's great if you have an AI that can spit out 1 billion tokens a second, but the question is, can you bloody read it that fast? And the answer is probably no. So as a result, instead of spending $3,000, $4,000 on VRAM and huge RTX whatevers, I've got 2 cheap as hell graphics cards from 15 years ago. I managed to get them to work, and they can run some of the latest Llama models. And
it's
peanuts.
Great, and I agree with you. And this is where I'm sure you've. Well, actually, you're more on the hardware side, but on the software side, you have these huge fights over what language is the best language to write in. And I always get frustrated with those. What's that?
What?
Yeah. Oh, sorry. Yeah. No. So I always get frustrated with those because my outlook when it comes to programming has always been, hey, like just pick the right tool for the job. There are some things where writing Python code is perfectly fine. There are some things where Python code is probably not the choice you want to make. You have to look at what you're trying to accomplish and then pick the right tool and then pull all that in. And I think the way AI is kind of being published or marketed is it's like it's the one tool that can solve all your problems. And maybe it is, but at the end of the day, it's like, well, you still have to use it in the correct fashion, like that works for you. So yes, getting upset about how many tokens something comes out. Well, does that work for you? Can you read that fast? Like you kind of have to have things work with you as you're going through and doing things. Back to the graphics thing. It's funny. Like 60 frames per second became sort of the standard of this is the frame rate you have to hit when you're doing your animations. And I kind of get it. Like I understand why they want to get it, because they don't know when the human eye is going to sample the screen, right? So the thing is you want to overclock your animations so they don't look jagged, right? So basically, if the eye is sampling every 24 frames per second, and you're pushing that out at a higher rate, well, then you're pretty much guaranteed that the eye is going to get a nice smooth string. But we don't have to go faster than that. You don't have to go faster than 60 frames per second in that situation. So now the challenge is that, well, how do I do more in that 60 frames per second, right? And that's really what we're trying to go through. We don't need to push that 60 frames per second to a higher level, but you've seen some people like, oh, I can go to 120 frames per second. I don't think you're going to notice it. Like, I don't, you might notice some animations be a little bit smoother, but I would argue that you're still only sampling them at 60 frames per second. It's just that because you've kind of filled in a couple extra little gaps with what you're trying to do, like that's where it's working out in your favor. But yeah, I agree with you 100%. Like, if you can't read 20 million tokens, don't produce it. Like, you don't need it. So yeah, I and to kind of bring this back to the telekinesis side, like that's where we really kind of say our tooling is the strong suit of what we're offering on a product side, because it's a tooling. The tooling is built around solving that problem. And as I said earlier in the podcast, I like it when you recognized a problem of where people were inefficient or spending a lot of time, and you can go in and create a product around solving that problem, because then there's value in what you're doing, right? And to your point,
what I would quickly actually say is probably a bit more than people wasting their time doing things they shouldn't be doing. It's actually more about safety, because you don't want people messing around with code that is going to be in a secure or a high risk scenario. You don't want them rewriting drivers and register definitions. You don't want that. You want them to say, no, don't touch it. The code works fine. Just update the configuration file.
Yeah. In a past life, I worked for QNX. It's an operating system that basically is. They took a microkernel approach where basically you only pull in the drivers that you actually really need. It's a little bit of a different approach than Linux, and it was all safety. It was all about safety, because it's like, if you don't need that driver, don't have it in the kernel, right? And you don't have to recompile, because when you deploy a QNX operating system to a target, you basically pick and choose what's going to get deployed. The kernel is very, very stripped down. It's very small.
Yeah.
And I really enjoy that. I really like that approach. And we used to have customers that were on very old versions of QNX. So this is where I started in support, when I said I started my career in support in QNX. And we had customers phone in and they'd be like, yeah, like, we haven't touched this in 10 years. And now after 10 years, we have this weird thing happening. It's not necessarily a bug, but it's just, we've never seen it before. Can you explain what's going on? And I go talk to the developers and they'd be like, I wrote that code 10 years ago. You're asking me, like, what were you doing 10 years ago? Can you explain to me? And so, like, you kind of have to go back and like look through some code and try and figure it out. But that, to your point, that's what you want. You want to achieve that thing where you can set it and forget it and not have to worry about it until, maybe 10 years down the road, something weird happens and you're just wondering why. It's not necessarily crashing. It's not necessarily causing a problem, but it's just behaving a little bit differently than it used to. And
in the case of telekinesis, it wouldn't behave differently, because the whole point is that your software is acting as the middleware. So it doesn't matter how the sensors change, as long as the configuration file is right, which is the only thing you touch.
Exactly.
It's the only thing you touch, it should be fine. Which brings me to a very important question, because I wanted to ask you about something, which is, in terms of the configuration sort of experience itself, is it purely command line, text based, or is it more like a GUI application where you can follow through?
We actually have a web. We've created a web-based tool. So basically, we started with web because we figured, in that environment, if you start with web, it's easier to do the team deployment.
Very quickly. It's really funny you mentioned about web, because over the past sort of 2 years, I've actually gone towards, I build web tools more than anything else, simply because it's cross-platform. You can deploy it once in a server, go on a browser, and it's there. And it makes a hell of a lot more sense than trying to compile something native to an operating system.
Exactly.
So it's funny you mentioned that, but go on, carry on.
No, I think again, like, when we talk about when you're architecting or designing a tool, like, you really want to think about, okay, well, how are people going to use this? How are people going to want to interact with this? Like, and when you're talking about messaging and you're talking about bringing teams together, well, web makes sense, right? Like, that's where you have to go, because you want that source of truth to be shared across multiple people. They all have to be looking at the same source of truth. So we started with web. It's hosted on our servers currently. We do have an on-prem solution if somebody doesn't like the fact that they're talking to our servers. So we'll go and set up a server on premise for you so that you don't have to talk to our servers. But with starting with web, we can now move it to a mobile application, or we can move it to a desktop application very simply, because it will still talk to the server, but it's just a browser. Exactly. So it makes a lot of sense that way. So that's kind of where we went, and that's what the tooling is. So it's all GUI based. It's kind of like Lego blocks. Like, you drag out the CAN bus, you connect it with a line to the telekinesis engine, and then you connect another line.
Oh, that sounds gorgeous. Oh.
So are you going to be at Hardware Pioneers by any chance?
Ask Jack. I'm not so sure.
Yeah, well, if you're going to be at Hardware Pioneers, stop by. I'll give you a demo, and then you can see it. So if you have a chance to stop by at Hardware Pioneers, or somebody from your company,
Are you going to be at Hardware Pioneers?
I am. Yes.
Oh, brilliant. Okay.
Yeah.
I might make the trip just for that reason. Then that sounds.
You should. We'll meet in person.
That sounds really interesting.
And then we could go hang out in a bar somewhere.
Yeah. When is Hardware Pioneers?
June 10th. Or 11th, 12th,
so
somewhere in there. I have.
We
to
may not be able to do that because I think we're going to be at PCIM. I don't think we're going to do that one. So we're in an event in Germany, I'm afraid, which is a bit sad. But I was going to ask you a question about. We're talking about browsers. Yeah, very, very quickly. I do kind of feel like that. And if there was one thing that I think that will change in the sort of next 10 years, right? I think the browser will become more of an operating system because I think if people want their web apps and stuff to become more closer to the metal, to make them run faster, that's the only logical step. Because right now you've got too many layers of virtualization, sort of like before you get to your program actually running on the bare metal.
I agree with you. I think I find it funny, right? Like when I was in public school, like way back in the day when I was really young, we all used icon systems here in Canada, and they were all cloud based. For like single server, everybody talking to a single server, and all the applications would just run on the dumb terminal, right? And then we moved away when RAM got cheaper and hard drives got cheaper, and everybody wanted to be like, I just want my stuff here.
2 seconds. When you said you were using computers when you were younger, was this when the hard disks were about this big? And
it was
like an i, and it was a PD. Was it a PDP-11 or something?
Yeah, pretty much. I think my first like real computer I got when I was maybe real's the wrong word, but my first foray into the computing world was when I was like 6 or 7 years old, and it was like a TSR Trash 80, sort of thing, and you basically saved programs on a little.
Right. This podcast just became show and tell ZX Spectrum.
Oh yeah, no, exactly.
Same thing. Parallel ports. Tape insert.
Plugged it into a tape deck, and you saved it.
Yeah, and you made that god awful noise.
Yeah.
No, absolutely.
And that was when I wrote everything in BASIC because that was the only thing it really knew how to do.
Everyone was coding BASIC on those machines.
And so it was a lot of fun. I enjoyed it. I mean, I don't think it made me too popular in high school, but I had fun because the geek revolution kind of hadn't made its way when I was that age. I
already knew I was talking to a nerd when I saw your Captain America shield behind you.
That was a gift from some team members of a
Nerds for life. That's what I say.
Yeah, it's actually real metal.
Nice.
I was actually they gave it to me, and I think it's the first time in my life. You probably picked up on this. This is the first time in my life where I was actually kind of speechless. Like I didn't know what to say when they handed it to me because I was like, wow, like this is awesome. Like it's real metal. It's got the real leather straps on the back.
Oh, lovely.
And it's beautiful. I'm really happy the team members all signed it for me.
You should have said team assemble.
Exactly.
That's what you should have done.
You should have been there when they gave that to me because that would have been great. I could have.
That's what you should have done.
Yeah, no, unfortunately, not so much. I was actually really speechless, but it was a very nice gesture. I'm a big Marvel fan. I was a comic book geek as well. So again, before they were popular. Didn't really endear me to my classmates or anything like that when I was growing up. But I mean, now it's great. I mean, I have a lot of stories.
Now you're an adult who has money and you can spend money on these things.
Exactly. And now I'm like, yeah, it's great. And it's created a great field. And I mean, I still ended up with a family. So I guess things didn't turn out that bad. All in all, I've always liked. Sort of the lessons that were in comic books, right? Because I think they're things that we can aspire to. Yes, they're wearing weird costumes and they don't dress up.
It's an art form.
That's okay.
There are far stranger things out there that people like.
Exactly.
Like Twilight.
If we move past that and we start to look at the Spider-Man one is the one that always comes up, and with great power comes great responsibility.
Oh yeah.
And I think that is true, and that should always be true. And but just the fact that the underlying, thing about the superhero is the fact that they could do anything they want. They choose to do the right thing, and that to me is what you kind of want to take forward in life. Is like we should always try and choose to do the right thing in any situation. Sometimes it's hard. Like don't get me wrong. I'm not saying like everybody's perfect or like if everybody did this it'd be perfect, because sometimes you don't know what the right choice is or what the right thing to do is. But at least if you're thinking about it, or at least if you have that as your underlying like this is what I'm going to do, more often than not, you should come out on the right side of the morality scale, right? So, anyways, that's kind of
that ties in well to TeleCANesis solutions, because you have to do the right thing, which is to deploy the solution into your projects, and that way you'll protect yourself for the future.
And not have to rerun all your tests and cause somebody to have to.
You need to have your own slogan. It's like, with great power comes great responsibility, but then it says something like but it has to be something like so don't change the bloody code or something at the end. You know what I mean? Just something
like
at the
end. I'll try and work that in. I'll try and get that. I'm not usually the marketing guy, but I can see if I can work that in some way, shape, or form. But I do like it a lot.
So when it comes to actually using TeleCANesis solutions, what would you say would be like the biggest challenge that engineers face when they want to use it? What would you say that it's like they're kind of like the barrier that kind of makes them resist?
Right now, it's the learning curve, because we're new, we've done things, we've structured things a little bit differently. We've tried to break things down into logical components of what you're trying to do. So we have transmitters and receivers, which we call connectors, and then we have codecs, which are your decoders and encoders. We have the messages themselves, which is like the global idea of what the messages are, and then we have routes, where when I get this message, where do I route it to, right? So that is kind of the hardest thing, is explaining to people, like, okay, well, you have a CAN receiver, it's going to receive data on the CAN, and then you're going to have a CAN transmitter, and it's going to transmit data on the CAN, right? And but pulling all those things out and hooking them all up, when you're looking at the complete solution, it can get a little overwhelming, because you're looking at it all, it's like, well, why can't I drag this line here? And it's like, well, because you haven't created a CAN receiver there yet, so you have to do that. And then when they do it, then the line gets connected, and they're like, oh, okay. Those things will clean up. Like, being a new product, we've only been around for about a year. We're still trying to clean up our rough edges. So I'd say learning curve is probably the biggest hurdle that we have to overcome. And we do that by writing good documentation with AI assistants, and shooting videos showing how people use it, and hopefully that it can resonate with people, and they can start to understand and kind of go through it. And then we'll also try to keep improving how we integrate. So one of the things I've noticed is we took our middleware takes a binary approach right now, but what we're going to do is we're going to switch that up and actually make it open source, because the middleware isn't where the real meat and potatoes is. It's the tooling, right? So we can open source the middleware up. That should make it easier for AI consumption, for example, right? Now that it's open source, AI can go out and read it and say, okay, well, this is what I think you need to do to set up this configuration. And then that way you can actually use tools to help you go along. The other thing is just building in more automation, where it's like, we'll set up the cloud server for you. You click this button, it deploys. And all of a sudden you've got a cloud server with a database set up in it that's running TeleCANesis, that can receive all these messages and collate for you, and then push them out.
So just sort of like reiterate to make sure I understand it correctly. Yep. The middleware that runs on the micro or the platform, that's more like an engine, but like you say, that's not the value. What really is the value is the configuration files that the engines are running, and to make those configuration files, you go to your web tool and you use all the graphical method sort of thing, put it together, and then it will spit out the configurations that you can then drop onto those. And then, hey presto, the middleware kind of does it. And I guess that means that I think that's the right approach. And I'll tell you why, because it's not so much about people being able to read it, understand it, and deploy it. It's the fact that it means that suddenly you can target any platform, because as long as someone knows how to port it or use it, it's fine. So RISC-V, ARM microcontrollers, PIC32s, whatever. Suddenly doesn't matter what you use, they'll all work.
100%, and that's the power of our tooling too, with the middleware approach that we've taken. Our middleware approach is all plugin based, as I said earlier. So you don't use the code that you don't need. So there's not a whole bunch of stuff baked in that you don't need. So if you just need CAN, it just comes with the CAN plugin. If you just need MQTT, it just comes with the MQTT plugin. Like we're plugin based, and we generate that plugin list based on your configuration. So you only need to pull those things in. But the way the engine has been architected is that everything that is needed from an OS level or hardware level has been abstracted out into one small library. So really all that has to be ported is that one small library.
The interface part. So you might have functions like read file, save file, something like that, and then you have to write the translation bit. So it patches, which is perfect. And on the topic of sort of like porting your code to different platforms, even if somebody else was to create their own application GUI to create these configuration files, the difference is that yours would be the one that would be safety certified. Yours would be the official tool. You'd be the one with the support and stuff. So it's like that. That is where the magic is. It's not going to be in the actual firmware side of things. It's actually those configurations and the tools and how the architecture comes together. Because I'm guessing that once you've created your whole structure, that becomes a project, that becomes a file. Then you get all these different parts, and so it's managing and organizing that. So when someone else comes in to deal with it, it makes sense.
You got it, and that's where it's the tooling is really the star of the show, and like what we try and say is we're not on the middleware side we're not doing anything like amazing. Like I hate to say that, but like I'm going to be completely honest. It's not like we've reinvented the wheel or come up with some new way of transmitting data. Like we're using standard prototypes to kind of accomplish what we're doing, right? And we've just put them all together. But the tooling, the idea that this can all be configured visually and it acts as a central source of truth is really where you're going to save your time. That's where you're going to save your effort. Because if you were to do this today and you wanted to write the tools, well, you'd have to write the tools anyway. Like if you wanted to save the time, you'd have to write the tools anyway. So you're going to do that. Let's say you would do that. Well, is it more efficient for your employees to be writing these tools that you may or may not use on this one project somewhere down the road? Or is it better just to buy the off-the-shelf tools, use the middleware, that code doesn't have to change, your employees don't have to write that code, and then they can focus on what makes your product the best product out there that you want to sell. And that's really what we should be going towards. And it's the same with anything. Like, I could write a Git server if I wanted to. Like you could write a Git server if you wanted to. Like you really could. But why would you when you can just go get GitLab or GitHub? Like what's the point of doing that?
It's reinventing the wheel.
What's that?
It's reinventing the wheel. Do you know what?
Yeah.
I've decided for good old giggles, I'm going to go and rewrite the stdio library for C. Why? Because I thought, why not? Even though the fact that it's already been done and someone far cleverer than me has already written it.
Yeah. Well, I had a former boss who used to tell me, he's like, have you ever written a memory allocator? Do you want to? And because we'd run into these situations where it's like our product at the time was using like the standard memory allocator that comes in libc, and when you go down onto microcontrollers, sometimes that's not always fleshed out the right way, right? So I'd always say, well, maybe we should write a memory, and that was his response. And he's right. Like there are people who have spent a lot of time writing memory allocators. They understand memory allocators. I could understand memory allocators, but I'm not going to be at their level. It's
like you and me have coded microcontrollers, and we understand how microcontrollers work at the register level. But even if we understand them at the register level, we have not dealt with every edge case to fully understand how they truly work, because there could be undocumented ways in which they behave differently. We don't fully appreciate or understand maybe how heaps are being moved around. So while you can sort of do something and it might work 95% of the time, if you're doing safety stuff, you don't want that 1% to come up suddenly and be like, oh, hang on a minute, your memory allocator just died, and it's going to die every time it tries and runs.
Yep. No, I was working for a customer, and it's kind of funny. We were doing this work for a customer, and at the time we were porting WebKit to their platform, and WebKit's huge. It was back in the day, and it kept crashing, and it took me a month to track down why it was crashing. And at the end of the day, it ended up that their memory allocator was doing something really, really bad underneath the covers. So, and it took forever for me to prove that it was that. And the whole time I kept saying, I think it's the memory allocator. Like, I really do believe it's the memory allocator. And people kept, no, it's your code. Like, you've done something silly. And hey, as a responsible developer, I took that and I was like, yeah, you're probably right. But my gut is telling me that it's this memory allocator. Lo and behold, I wrote a test case that finally proved that I was right. It was the memory allocator that was doing it. I have on my shelf back there, there's a My Little Pony, because what happened was I was telling my boss, I finally became very adamant that yes, it is the memory allocator. Like, it's definitely
it's the unicorn.
Yeah, it's definitely and he looks at me and he goes, I still think it's your code. I'm like, okay. He's like, if I'm right, if I'm right, great, we solved the problem. You fix your code, you learn. He goes, what do you want if you're right? And unfortunately, I said a pony. I should have said at the time, I should have said a raise. That would have been a better answer. Anyways, he bought me a My Little Pony because I was right. It was the memory allocator.
You know what? It's funny you mention that because I'll just give you a quick test case that actually happened this morning at 3. It was like 3 or 4 in the morning. I've got a new son. You know, he's 7 months old now, but he wakes me up sometimes. So I just start work. Thank you very much.
It's awesome.
I sort of start work early now. Anyway, but this is interesting because I'm not going to say whose platform and software environment it is, but I was using this software and platform environment, and I made a function whereby I pass. It's a function. It just updates a label on a graphical display, and in there you pass a float like temperature, right?
Yep.
And I was passing it through, and it kept reading 0, and I was like, this doesn't make any sense. Why does it keep coming across as 0? I went to my main program. I was looking at the numbers. No, the numbers are right. I was like, this is really strange. I thought I was completely stupid, and it turns out, for reasons that I can't understand, the compiler that this company have built doesn't understand how to pass a float. So the only way you can pass a float to a function is to have to pass it by reference.
Oh,
so then you load it inside the function. So instead of going like, you know, function float f, you have to go float star f because you have to then go into there and then pull that value through because it must be something to do with the way that it's getting passed on the stack or something.
Probably 100%.
It doesn't quite understand how to, because I know floats are weird number formats.
Maybe it can't allocate the proper structure or something.
Or maybe the registers don't. Or maybe the registers don't exist. I don't know.
There's that, yeah.
But it's just funny how like I thought I was stupid for about 4 hours straight, thinking, why can I not pass a float to a function? Am I stupid? Nope, not me. And I was completely I was completely vindicated, and I just was so happy when I found it was not my fault. Because even ChatGPT was going, I really don't understand why this is not working. Yeah, and we were both like, oh, what?
And again, this is why you need a human. Because these are the things that it's not going to get to a point where it can reason. It would not have thought of that. It would not have thought that, there's a problem in the compiler somewhere that you can't do it this way. You have to do it this way. And sometimes, I think human beings, the way we get around those sort of things is we start doing trial and error. Like you probably started trying different pieces of code.
We think about the obvious and we think about the unobvious. We sit there and think, what's it actually doing when it sends a variable? What is that variable doing in RAM? How is it being shifted around? Is it acting like a normal machine, or is it like, because it's embedded, it hasn't got a floating point unit? So maybe it's confusing where bits and bytes are and stuff. So it just comes back as 0 anyway. So, like you said, the human can look at the obvious and the unobvious, whereas AIs tend to look at the generic sort of most obvious solution to them. They would never go, maybe it's something really bizarre, because 9 out of 10 times it wouldn't be that.
No. Yeah,
but the human has the instinct to go, do you know what? I think it could just be that 1%, like you did with your pony problem.
Yeah, exactly. Like it's not me. Like you do have to sometimes sit there and say, like, this is somebody else's problem. The trick of it, and I think this is the part that most people forget to do, is you have to prove it. Like that's like what frustrates me sometimes is when you're dealing with people and they're like, oh, it's this, and you're like, okay, well, where's your proof that it's this? And it's like, well, I can't prove it. Well, then we don't know. Like there has to be a proof side of it where we go in and we say, okay, this is what's actually happening. In my case, what I did is I wrote a little application that like queried the heap and did a heap coherency check on it, every single line of code. So when the code would execute, it would do a heap coherency. Ran code very, very slowly. Let me just tell you, it was the slowest running code you've ever seen. But then when I hit a certain line, the heap was suddenly incoherent, and nothing should have made the heap incoherent, except in this case, it loaded a library. And when the library was loaded, that's when the heap became incoherent. And so like these are things where it's like, that's the sort of check you have to do to prove things, right? So.
Well, this has been an absolutely fantastic conversation, but we're going to have to now wrap up the podcast because we could talk on for hours about this stuff.
I told you that at the start. I told you between me and you, we could probably do this for 3 hours.
Which is why I definitely think we could definitely do a part 2 and 3 to this, because I think there's a lot of interesting stuff to cover, because it goes way beyond, because we haven't even touched on application spaces, we haven't touched on industries, and how these solutions can be sort of deployed. But what I will ask you as a final question for our audience is, if they want to get involved with TeleCANesis solutions, what would you recommend that they do?
Just go to telecanesis.com. Check it out there.
Would you like to spell it out for the audience?
Oh, yes. TeleCANESIS.com. because yes, don't spell it the normal way, because
it will not come up.
Canadian, and we like CAN buses. But we do more than CAN buses, which is why we added the Canadian part. So yeah.
And all I can say is thank you ever so much for taking the time here today. It's been an absolute pleasure.
I really enjoyed it. This was my first podcast ever. It was great. It was awesome.
Fantastic.
I was a little nervous coming on here, but you made this effortless. So I really
most
enjoyed talking to you. It was great.
I got the introduction done in one go.
Yeah, there you go. Awesome.
Fantastic. Thank you ever so much for taking the time today.